Okay, so let's together begin a brand new chapter for discussion of the questions in the books. So we are going to continue with the chapter 4, group 2. So hopefully you all are ready for this. So with analyzation, let's begin. Okay, so let's have a look at the section A first. So section A objective, question number 1 sounds like this. The carbonates of group 2 element from beryllium to barium decompose according to the following equation, XCO3 give XO plus CO2. Which of the following combination is correct when going down to the group 2 carbonate? So A, the T's energy of XCO3, the T's energy of XO, and the decomposition temperature of XO3. Okay, so as we already know, the T's energy is directly proportional to the charge, yet inversely proportional to the inter-ionic radius. So when going down to the group 2, as the ionic radius increases, okay, we said that the T's energy is directly proportional to the charge, okay, yet inversely proportional to the inter-ionic radius. So as going down to the group, so the ionic radius increases. So as a result, the T's energy decrease. So it is the decrease for both XCO3 and also XO. Okay. So in terms of decomposition temperature of XO3 increase. So the best answer in here will be boy B. Okay. So that is how you answer for question number 1. Then we goes to question number 2. Okay, the following observations are obtained when the following solutions are added to 0.1 mole of aqueous sodium Mn plus ions. So no observable changes when 200 centimeter cube of aqueous solution of NaOH 2.5 mole per decimeter cube is added. A white precipitate is formed when 250 centimeter cube of NaOH is added, and on addition of the 200 centimeter cube of sodium sulfite Na2S, and effervescence occurs. So what could be M? So what is this question in here actually trying to ask you in here is 1 and 2 actually try to show that the hydroxide of the Mn plus is soluble in sodium hydroxide. So Mn plus could be aluminium or lead. So another possible is zinc. So addition of Na2S releases H2S that give effervescence. Okay, and this is a very specific case for this lead ethanoate. So the lead will become black. So in another word, it is not lead, showing that Mn plus is acidic. So Mn plus must have a high charge density. Therefore, Mn plus that we are talking about in here is aluminium. And this is the equation when aluminium ions is hydrated inside here. Now, to be honest, these are slightly out of syllabus already. So that is why you don't mind too much about this question. It's also my fault that you put this question because it was a very old past year question. You were not even born yet when these past year questions come out. Okay, so don't worry about that. Just know that there is such things. Okay, so this is the answer is A, aluminium. Okay, so don't worry. I cannot understand, never mind for this question. Okay, sorry for that. Okay, so for number 3, which of the following statement explain that increasing thermal stability of the group 2 nitrate from beryllium to barium when going down to the group 2 nitrate? So in here, cationic radius increase is correct. Okay, so size of the oxide ion is smaller than that of the nitrate ion, which is also correct. Polarizing power of the cation decreases is correct. Okay, and the stability of M2 plus and NO3 minus increase, which is also correct. Okay, so for the second statement, even though it is correct, size of the O2 minus ion is smaller than the NO3 minus, but it doesn't explain why is it that when going down to the group 2 carbonate, the group 2 nitrate, the stability increases, because in this case, for all the anions, they are the same nitrate ion, isn't it? So it does not influence the changes in here. So the best that explain all of them goes to the changes that happens inside the cation. Okay, so therefore 1, 3, and 4 is correct. Okay. Okay, so the answer in here is C. Number 4, solubility of the group 2 sulfate in unit gram per 100 gram of water are given below. So you have compound MgSO4 and BaSO4. So from here you can see that MgSO4 is dissolved inside here. That means it is soluble. And whereas the barium sulfate, you have a very little solubility, so it's sparingly soluble. So that is what they are trying to explain to you. Okay, so which statement best explain the above data? Number one, the size of the barium ion is greater than that of the magnesium ion, which is actually correct. So but it is not actually the best answer yet. B, barium has a lower ionization energy compared to magnesium. So similarly, even though this statement is correct, but it has no relevance towards the changes in here. Okay, so barium sulfate has a significantly lower lattice energy than the magnesium sulfate. So in here, due to the large sulfate ions, the changes from the barium to magnesium is not significant, okay, not significantly lower. It's not that significant due to the large sulfate ion. So C, the statement is inappropriate, okay? And finally, the magnesium ion has a much hydration energy compared to barium, which is correct. So in here, we say is that the enthalpy change of the solution is equals to the enthalpy change of the hydration minus lattice energy. So it is because of the hydration, which is so much higher. So that is why the magnesium is more soluble than that of the barium in here. Okay, so the best answer in here is donkey. Okay, so that is how we are going to describe for question number 4. Then we go to question number 5. Carbonates of group 2 element from beryllium to barium in the periodic table decomposes on heating. Which of the following explain why thermal stability of MCO3 increased down group 2? Okay, so let's have a look at the solution A. The radius of the M2 plus ion increased, which is actually correct. Okay, but is it the best? Let's have a look further. The lattice energy of MCO3 decreases, which is also correct because when going down to the group 2 carbonate, as the size of the group 2 ion increased, the lattice energy decreased. So this radius in between the M2 plus ion also increases, so the charge density decreases. This statement is also correct. And the distance between M2 plus and CO3 minus actually increase. They are trying to state the inter-ionic radius. Okay, so in here, which statement best explain that? Why is it that the lattice energy MCO3 described? So A is the primary factor that leads to C. C will lead to D. D will finally lead to B. So the most conclusive answers in here, which explain why does the stability increases in here, is C, because of the high charge density in here. Okay, while B and D does not explain the stability. Okay, B and D is more towards explain solubility because it's lattice energy in here. Okay, okay, so that is for number 5. Okay. Okay, so number 6. Charge density of the barium ion is similar to that of aluminium ion. Which statement is true? Barium oxide is basic. No, barium oxide is amphoteric. Barium chloride is covalent, which is correct due to the high charge density, hence high polarizing power of the beryllium that causes barium chloride to have a covalent compound. And then number 3, aqueous beryllium chloride is acidic, yes, because it's undergo hydrolysis inside water. So, and then number 4, barium hydroxide is amphoteric, which is also correct. So the best answer in here is 2, 3, and also 4. So answer is donkey D. Okay, number 7. The following table shows the observation obtained when aqueous solution of several cations of group 2 elements in concentration 0.1 mole per decimeter cube react separately with 1.0 mole per decimeter cube of aqueous sodium sulfate in here. So you can see that magnesium, no precipitate, calcium, small amount, strontium and barium, large precipitate. So what are they trying to tell you in here is as going down to the group 2 sulfate, the solubility decrease. Okay, the solubility decrease. Okay, so which statement best explain the above observations on the descending of group 2 element? So the reactivity of the element decrease. It's not about reactivity, so this one is incorrect. Solubility of the group 2 sulfate increases, which is wrong because it is decreasing, not increasing. So B is also wrong. C, the value of KSP increase. value of KSP increase means that it's more and more soluble, but in fact, it is more and more insoluble. So C is also wrong. And finally, for D, the decrease in the hydration in the cation is greater than that of decrease in their lattice energy, which is correct. As I mentioned just now, because enthalpy change of solution is equals to the enthalpy change of the hydration minus lattice energy. So in the changes graph, okay, so we say that the changes in the hydration is more significant than the changes in the lattice energy as the due to the large sulfate ions that causes the lattice energy does not changes significantly. So as a result, the changes inside the solubility inside the solution become more endothermic, hence become more and more insoluble. So the best answer in here is donkey D. Okay, so that is how you solve for question number 7. Okay, so in metallization, let's move to question number 8. Strontium is an element of the group 2 of periodic tables, which is situated between calcium and barium. Which statement is true? A. Strontium ion has a higher charge density than calcium, which is incorrect because strontium has a larger radius, therefore charge density is supposed to be lower. Okay, so number 2, strontium sulfate is less soluble in water compared to calcium sulfate, which is correct because solubility decreases. So number 2 is correct. Strontium carbonate is more difficult to decompose than barium carbonate when heated, which is wrong, as barium carbonate has a higher decomposition temperature compared to that of strontium. And finally, strontium nitrate is more difficult to decompose compared to barium nitrate, which is also wrong. So the best answer that represents all in here is B. Strontium sulfate is less soluble in water than calcium sulfate. Okay, number 9. Which statement best explains why thermostability of the carbonate of group 2 metal of the periodic table increases when going down to the group? So we are going to say is that A, polarizing power of the metal ions toward the CO3 2 minus decrease. So this statement is correct. Correct, because when going down to the group 2, the cationic radius increase, therefore polarizing power decrease. So therefore, the polarizing towards the CO3 2 minus decrease. Okay. Okay. B, the strength of the ionic bond of the metal carbonate. Okay. So this will, as we say, is that polarizing power decrease. That means covalency decrease. When covalency decrease, conversely, ionic characteristic increase. Okay, so the statement B is correct. Okay, and so far it is the best that described. C, the radius of the metal ion increases is correct, but it is the primary factor. And then D, the electronegativity of the metal decreases. So electronegativity has nothing to do with the thermal stability here. So in here, if we want to, you see in here A, B, C are correct. Which one is the best answer? So usually we look for the most conclusive because initial factor is because of radius. Large radius means low polarizing power. Then low polarizing power means that high ionic characteristic. So ionic characteristic is the one that concluded everything in here. So the best answer that describes why is it that the thermal stability increases is due to D. The strength of the ionic bond in the metal carbonate increases. Okay, so that is how you describe it. So that is for number 9. Then we goes for number 10. Barium hydroxide decomposes the barium oxide when heated to 138. Which statement may explain why barium hydroxide decomposes at such temperature? Okay, A. So it's because the barium ion is small, which is correct. Okay, it is indeed small and has a high charge. Therefore, it has a high charge density, correct? So the OH bond in the BOH is polar. So this will not influence the solubility, thermal stability. And finally, the BeO is a covalent compound. No, BeO is actually ionic compound, but has high covalent characteristic. So the best that explain all of them are boy and B. Number 11, which one of the following equations represent the reaction that occur when calcium nitrate is heated strongly? So this one you have to memorize the equation. So the best equation that describe the decomposition of the calcium nitrate is actually donkey D. So 2CaNO3 give 2CaO plus 4 NO2 plus O2 in here. Okay, number 12. Which of the following conclusion can be drawn From the observation that strontium sulfate SrSO4 is precipitated immediately, whereas the solution of the strontium chloride with sodium sulfate are mixed. So this is due to the solubility again. So SrCl2 is a very weak base. It's not appropriate because acidity and basicity in here does not influence the solubility. B, strontium sulfate predominantly covalent compound. No, strontium sulfate is still an ionic compound after all. So C, strontium sulfate is strongly hydrated. No, it is because it is weakly hydrated. That is why it becomes less soluble inside water. So the C is strong. So the best answer that describes all of this is donkey D, because SrSO4 has a very low solubility product, therefore do not form precipitate easily. Okay, so this is how we are going to answer question number 12. Immediately we go to question number 13. Magnesium oxide is used in the making of the lining in furnace blast. The procedure begins by extracting from seawater where aqueous calcium hydroxide is added to the seawater. So the CaOH2 plus MgCl2 give MgOH2 plus Cl. So in here you can see that we form a precipitate of MgOH2. The magnesium hydroxide is then filtered off and roasted, which on the following comparison between calcium and magnesium explain why magnesium hydroxide is formed. So in other words, why is magnesium hydroxide easier to form? Okay, A, it is because magnesium is less electropositive than calcium. No, actually magnesium is more electropositive than calcium. Okay, B, the magnitude of the lattice energy of MgOH2 is greater than that of the COH2, which is correct because Mg2 plus has a smaller ionic radius compared to Ca2 plus. So B is possible. And C, NW change of the hydration is less exothermic than Ca2 plus, which is wrong because of the smaller size of the Mg2 plus. Therefore, you have a higher NW change of the hydration. So C is wrong. And finally, the D, magnesium is lower than calcium in reactivity series, which is also wrong in terms of E0 value. Magnesium is more negative than calcium. So the best answer that describes why is it that calcium and magnesium, why magnesium hydroxide is preferably to be formed, because of the magnitude of lattice energy is greater. Okay, so the best answer in here is B. Number 14, which of the following is a group 2 periodic table? So you have to know the group 2 of the periodic table. Number 1, it must have a relatively high melting point, be above than 300, that is for sure. And then number 2, so if above than 300, automatically this A and B is already wrong. Okay, so C and D, if you look at their conductivity, in terms of the in terms of density, okay, density of non-metal, density of group 2 are supposed to be quite lower, not this higher. So when D is very high, that means that it is not belongs to group 2. And finally, in terms of the electrical conductivity, group 2 is a good conductor. So that is why all of them describe the best answer that describe the whole thing in here will be C. Okay. Okay, so that is how you solve for question number 14. Okay. Okay, so with that next session, let's immediately move to question number 15. Okay. Okay, which of the one mole of each of the following compound is strongly heated with a Bunsen flame, and any gas produced is collected at room temperature and pressure. From which compound is 24.4 decimeter cube of gas is likely to be collected? So in here, you're heating 1 mole. At the end, you get 24.4, which is also 1 mole of gas. So which one is the possible gases? So you have to write all the decomposition temperature for the A, B, C, and D. However, BeCl2 does not decompose. BeCl2 does not decompose. Whereas if BeCl3 we decompose to become BeO plus CO2. So the ratio of the gas CO2 is 1:1. So B might be the answer. So in terms of BeNO32, because based on the equations in here, if you have MnO32, you give 2MO plus NO2 plus O2. So in this case, you have 2 gases, which is NO and NO2 and also O2. So the stoichiometry is 2 to 5. Okay, and finally, for the barium hydroxide, you form MOH2 to give NO plus H2O. But H2O in this case is liquid. Okay, so the best answer that describe all of them here is boy B. Number 16, which of the following statement is true for the strontium compound? Number 1, strontium hydroxide is dehydrated on oxygen on being heated. So as long as you are hydroxide, is when you group 2 hydroxide, when you heat it, even for the smallest atom, it can be easily dehydrated. That means remove the water away. So number 1 is correct, but not the best answer. Number 2, strontium react with water to produce strontium oxide hydrogen gas, which is true. Okay, so this is the type of dehydration. Sodium carbonate decomposes at lower temperature than calcium carbonate, which is true. Which is not true, sorry. Which is not true, because strontium carbonate is supposed to have a higher stability compared to calcium. Okay, so C is wrong, and then D, strontium does not burn in air. Yeah, it does not burn in air. Okay, so but it's very reactive due to the highly electronegative element species in here. Okay, so the best answer that describe all of them are 1 and 2 only. Okay, so that is how you are going to solve question number 16. Then we are going to have a look at question number 17. Which of properties of the group 2 element and their compound increases when going down to the group? A, stability of the nitrate of heat, which is correct. B, the pH of the aqueous solution, pH of the aqueous solution, so it is also correct because it depends on the situation, but mostly acidic solution will fit better. C, the solubility of the group 2 sulfate. So solubility of group 2 sulfate decreases, not increases. And finally, the magnitude of the enthalpy change or hydration of metal ion decreases, not increases. So the best answer in here will be A, okay, stability of the nitrate heating. Okay, so with that, that is for number 17. Immediately we go to the 18. So number 18 sounds like this. Which diagram shows the variation of this ionic radius, of group 2 element B and G and calcium, strontium, and barium, which increasing proton number. So which of the following represent the variations? So the best variations in here try to show about the atomic radius and also proton number is A, okay, because as ionic radius increase, the number of proton also increase. Hey, wait, the bullet. It's supposed to be B, it's supposed to be B. Supposed to be B. Ionic radius increase. It's going down to the proton number. Okay. Okay, supposedly increase. Okay, so number 18 is B. Okay, number 19, which change occurs in the magnitude of these 3 properties? The T's energy, enthalpy change of hydration, and the solubility of group 2 sulfate. So all of them, when going down to the group 2 sulfate, are decreasing. Okay, so the best answer in here is A. Very straightforward questions, I believe. Okay, so that is for number 19. Then we go to number 20. Which method is the most suitable for extracting barium? So to extract barium, because barium is a very electropositive metal, so the best way is through electrolysis. So if you use aqueous, it won't work, so you have to use molten. So in here, the best answer in here will be B. Okay, so you electrolyze the molten barium chloride in order to get the pure barium in here. Okay, so 21, the group solubility of group 2 metal sulfate decrease as proton number increase. Which factor affects these trends? A, atomic radius of the metal atom, which is correct, okay, but not the best. B, enthalpy change of formation of the sulfate ion, which is also correct, but it is not the best. So the real one that still influence the solubility of the group 2 sulfate is still the enthalpy change of the hydration. The metals. Okay, so the answer is C. Okay, so any questions so far? Okay, so no problem. Then we go to question number 22. Radium with the proton number 88 was discovered by Marie Curie in 1898. Some of its properties are compared to those of barium. Which property of radium is unexpected when considered it will be the last group of the group 2 element and their compound? So in terms of enthalpy change of hydration, so radium has a lower enthalpy change of hydration because due to the large size. So when you have a large cationic radius, the hydration ability decreases. So that is why it is less exothermic. So A is wrong. B, ionic product. In terms of ionic product, radium, it has a larger size. You have a larger ionic radius, which is correct. In terms of solubility, just now we have already discussed about the solubility. We said that when going down to the group, solubility decreases. Okay, and finally, summation of first and second. But if you look carefully, radium has a surprisingly higher first and second ionization energy, which is anomaly here, because usually for the case of the radium, when you are in a lower position of the periodic table, usually you are less endothermic than expected. So in here, this is where the anomaly happens, and therefore your answer is donkey D. Okay, so that is for question number 22. We continue to question number 23. Calcium is a group 2 metal which can undergo 2 reaction routes. Which set contain 3 different compounds in here? So you have to understand how does the things works in here. So sorry, it's calcium, not barium. Typing error. Sorry, take a little time. Okay, so there you go. Okay, so in here, the graph goes like this. When calcium react with oxygen, you form calcium oxide. So when calcium oxide dissolve in water, you form calcium hydroxide. And then when calcium hydroxide evaporate to dryness, you form back calcium oxide plus water. So you can see in here, T and B are the same. Okay, so in the case of calcium when dissolved in water, so calcium hydroxide is sparingly soluble in water. So it is calcium hydroxide. But previously, our question also U also contains the same compound, which is calcium hydroxide in here. Whereas W is the calcium oxide plus nitric acid. So when you dissolve in the nitric acid, so you form a calcium nitrate. Okay, so therefore the best answer in here will be B. Okay, UVY, I have 3 different compounds in here. Okay, so that is for question number 23. There it goes for question number 24. On strong heating, calcium sulfate decomposes on calcium oxide and sulfur trioxide. The compound of calcium carbonate decomposes at a lower temperature than calcium sulfate. Which factor best explains the greater stability of the CaSO4? Okay, so how do you explain the thermal stability in here? So we are going to say that calcium chloride has a higher lattice energy than calcium sulfate, which is wrong because carbonate has a smaller ionic radius compared to sulfate. So that is why it has a lower, calcium carbonate has a higher lattice energy, which is correct. Number 2, B. CO2 is smaller molecule than SO3, which is correct because CO2 only has 3 atoms, while SO3 has 4 atoms. Number C. CO3 2- is more easily polarized than SO4 2-, which is actually wrong due to the larger atomic radius of the sulfate. So that is why it is easier to be polarized. Okay. And then finally, D, the charge density of carbonate is greater than that of the sulfate. So in this case, in terms of charge density, yes, carbonate is greater than that of the sulfate. But in terms of thermal stability, the one that explained that why is it calcium carbonate has a higher lattice energy is due to the difference in the charge density inside the carbonate in here. Okay, so the best answer in here is donkey D. 35. Barium sulfate occur naturally as chloride, which is a solid ore. Magnesium sulfate, however, occur in many solutions. Explain the difference between the two sulfate compounds. So in here, after Google it, so you can eventually find out that barium ion are less readily hydrated than magnesium ion, which is incorrect. So barium sulfate has a stronger crystalline solid, which is also incorrect. Barium sulfate has more resistance to oxidation than magnesium sulfate, which is not appropriate. And magnesium sulfate is hydrolyzed by natural acid product, but barium does not, which is also incorrect. So the best answer that describe why is it that the magnesium sulfate is occur in solution is due to A. Barium ion are less readily hydrated than magnesium ion. Okay. Okay, so immediately we go to 26. Lithium resembles the magnesium in chemical properties. Which properties of lithium salt does have? A. Lithium carbonate decompose on carbon dioxide on being heated, which is correct. B. Lithium nitrate gave oxygen as only blood needed, which is also correct. So lithium sulfate is soluble in water. Yes, lithium sulfate is soluble in water. So the best answer in here will be, we are looking for incorrect. So the best answer in here is B, boy. Okay, 37. In room temperature, aluminum chloride exists as a dimer Al2Cl6. By using the information, which is the following is most likely the structural formula of barium chloride under room temperature pressure. If aluminum chloride can already exist as a dimer under room temperature pressure, same goes with beryllium chloride, which is an anomaly inside here. So therefore, the best answer that described in here is donkey D. Okay, answer is donkey D. I highlighted for you for a while. Okay. So that is for number 27. Then we go to 28. The graph represents the changes in the mass when 1.0 gram of the calcium nitrate is heated to decompose. So when 1.0 gram is heated to decompose, so you see from the graph in the first one, this is given from the hospital that tells that my nephew is having problems with his heart. So in here, what are we going to discuss in here is, you see here, in this case, this is the heated by calcium nitrate. Okay, so if you compare to strontium nitrate, which is harder to decompose, so harder decompose means that hardly break. So what is in terms of mass for the calcium, this one? So since it is harder to break, so the best one is still donkey D. Okay. Okay, so that is for number 28. Then we go to 29. Which element is likely to have electronegativity similar to aluminium? This one never needed to explain. B is the best answer, beryllium, because of the anomalous behavior. Okay, number 30. Graph below shows the decomposition temperature of group 2 carbonate, magnesium, calcium, and strontium. Which factor makes magnesium is the least thermally stable? So due to it has a small cation polarizing a large anion. Okay, so the best answer that describe this is boy B. B, B, not there. Sorry, I made a mistake. Okay, but my explanation says so. Okay, so I guess that is all for our lesson today. So I discussed only 30. Tomorrow we will continue our discussion for 31 and the whole structure questions. Okay, so hope that you all will go and ready to prepare the structure question tomorrow. And so wait a second. Okay, so is there any questions?